27 years in the communication industry. Bernie recently retired from Motorola after over 32 years of service. He was honored as a Radio Club of America Fellow in 2004, is a life member of the IEEE, and is currently chair of TIA TR8.18. This morning, he'll help us understand the factors causing the mystery of what happens to our coverage when we go narrowband. Bernie?
Well, good morning. Hope everybody enjoyed the trip back here. I was kind of wondering if I was going to make it before the meeting was over. Good grief. I guess you gave my overall credential, but I've been involved in simulcast and coverage ever since I joined Motorola. But before that, I was also involved in microwave and was also a signal corps officer. So that's where the 47 years of experience come. Got my radio, first class radio, telephone license, ham ticket, all those good things. So I want to talk about the impact on coverage of narrowbanding, and at the end I'll talk a little bit about the impact on simulcast for narrowbanding. So everybody asks, what does it do about coverage? And I always answer, it depends on. And the reason I do that is because I used to have to take care of the thundering salespeople Motorola had back in the good old days. And I was always afraid to give yes-no answers because they would ask the question framed in such a way that they leave off the part that would cause me to say no. So I always try to talk about things in general. In going to narrowband, the migration process is pretty important. I think everybody knows about the dual mode radios and things like that. You can't just suddenly switch from wideband to narrowband in one day unless you have planned and properly gotten the right radios and tested it before you switch it. And also training of the users is important because there will be some differences, and that's some of the things we'll talk about. It depends on your link budget, and that's where the primary difference between wideband and narrowband comes in, is the size of the link budget. There's also trade-off in sensitivity and interference protection. A lot of the radios have what I'd call a dynamic receiver effective noise bandwidth. That means when it goes from wideband to narrowband, they can actually switch the bandwidth of the receiver. In some cases they don't. They use a compromise IF that's a little narrow for wideband, but it's wide enough for narrowband. So there's these kinds of trade-offs. Now I'm going to talk in generalities about narrowband analog. And in that case, I'm going to use 8 kilohertz as a typical IF bandwidth. And that's what they use in Europe, and that's what some of the Motorola products use in general. And I think most manufacturers are in that ballpark because that gives you a James channel reflection ratio that meets the TIA minimum standards. Talk about the coverage area, the terrain, and the environmental factors. I guess I missed the previous presentation. They were talking, I would assume, about propagation and the fact that you need to look out on each radial and take into account the propagation model, but also the terrain and also what's on the terrain. Is it desert? Is it heavy forest? What's out there? Because that affects the coverage you're going to get. And I'll talk a little bit about simulcast. Now, my main job over the last years has been taking ownership of TSP 88. For those of you who don't know what that is, it's a 3-volume set right now. That the first set has the values of the different parameters that you need to know to be able to model performance. And that would be carrier to noise ratios, defines the different modulations, gives you a waveform of the modulation, gives you a recommended receiver bandwidth. All those kind of things are provided in that document. The dot 2 is propagation. It goes through all the different kinds of models that are available, and it gives you databases or access to databases through the internet by giving you the links so that you can have the more recent databases available for use with your propagation model. And then the third one is how to do an acceptance test plan and dry. I'm going to get it also more. And how to deal with interference. So those are the three documents, and I will keep referring to them every now and then. But in the link budget, I have from TSB 88.1 a comprehensive view, waterfall view, if you would, of what a link budget looks like. And on the left, I have a simplified explanation. And this is probably, for this audience, this is probably something I don't need to go in, so I'll just go on the simple side. You calculate the effective radiated power, calculate the propagation loss to some point that you're evaluating. That gets you the signal level that you have at that point. But now you need to know what the noise floor of the receiver is, and the way you find that out is you take the manufacturer's published sensitivity spec and subtract the carrier to noise ratio, static carrier to noise ratio, and that gets you where the noise floor is. We call that the inferred noise floor. Then you add to that the faded sensitivity. And the faded sensitivity is how much carrier to noise do you need to get a certain level of performance. And the level of performance are defined as a DAQ3, which is equivalent to a static SINAD of 17 dB. DAQ 3.4, which is equivalent to intelligibility to a 20 dB SINAD static. And then a DAQ of 4 is equivalent to about 25 dB SINAD static. But this is in the presence of fading that we're talking about, so those numbers can get fairly large. And this is the fundamental difference between wideband and analog, is the value of the faded sensitivity, the value you need to add for your faded sensitivity audio quality. Now there's other factors you have to take into consideration, such as booming losses, antenna efficiencies, and when you're all said and done, you end up with a margin that's left, and that margin is what determines the reliability or the probability of achieving a particular audio quality. The only difference on a typical case that you're migrating from wideband to narrowband is going to be the carrier to noise and the bandwidth of the receiver. All the other things should remain the same. I mean, you're not changing anything else unless you need to because of the changes that you see in coverage. So here's an example of a 25 kilohertz and a 12.5 kilohertz analog. You need 17 dB carrier to noise faded to get to a DAQ of 3, but for the analog, you need about 6 dB more, because reduced deviation is a 20 log kind of scenario. So you cut it in half, so you're going to lose about 6 dB of the audio. And as I came in, I heard talking about hum and noise. Well, your audio went down, but the hum and noise in the receiver remained the same, and that's why that spec degrades in analog. So calculating using 16 kilohertz, you come up with a noise floor of minus 122 dBm for the wideband and minus 125 dBm for the narrowband. You add the static carrier to noise, as I mentioned, and you get a minus 118, and again, you get a minus 118 for the narrowband too. So on a spec sheet, you're going to see those radios saying they have the same sensitivity, but they don't, because one of them, the narrow, requires 6 dB more